Hi, in this problem we're going to continue to model Tristan the werewolf and how he reacts to the rise of the moon. So since he's a werewolf, when the moon rises, the number of hairs in his back is going to grow and grow pretty quickly. And we'd like to figure out how fast it's growing, the hair is growing. So taking measurements, scientists have determined that after 0 seconds, there are 10 hairs on his back. That's all he's got to start with, is 10 hairs. After 10 seconds after he sees the moon, he gets up to 50 hairs, after 20, 120 hairs, etc. Now, what we're really interested in is how fast is Tristan's hair, uh, growing, and how many hairs he's got. What's the rate of change? So that's the derivative. We want to know the derivative. So given this data about h of t in this table, we'd like to figure out an estimate, at least, of what h prime of t should be. Well, since we have a table, we have to do the best we can, and we take the smallest intervals possible. So for example, to figure out what this is, which is h prime of 0, h prime of 0 is approximately the average rate of change over the smallest interval we can find that starts at 0. This one is 0 to 10. So we're going to have t vary from 0 to 10. So the denominator will be 10 minus 0. And then the y values, the change in y values is 50 minus 10. So that's the average rate of change over the interval between 0 and 10. That's the average rate of change formula, in other words, the slope. And if we take this difference, we get 40 divided by 10, which is going to be the same as 4. So as an estimate of how fast hair is growing on Tristan's back, at 0 seconds, we're going to say 4. That's 4 hairs per second, right? That's the right units. Now, then we can move on to try to estimate what happens when time is equal to 10. How fast is hair on Tristan's back growing at that point? Well, in that case, we have two options. We could either use the interval on the right, or we could use the interval on the left and take the average rate of change for those. And in fact, what we're going to do is take the average of those two. When we have this here, we have a choice. We have a choice between the right interval and the left interval around 10. We're going to take both and then divide by 2. Okay, so let's do that. So the interval to the right, that's going to be 120 minus 50 divided by 20 minus 50. That's the average of 20 minus 10. That's the average rate of change over the interval between 10 and 20. Okay, and that's equal to, well, 70 divided by 10. That's what 120, right? And that's the same as 7. So the average rate of change between 10 and 20, that was 7. We already figured out the average rate of change between 0 and 10. We just did that a few seconds ago, and that was 4. And now to figure out what happens at 10, what we do is, to get the best estimate, is to add 4 and 7 together and divide by 2. So that's equal to 11 over 2, which is the same as 5.5. So our estimate of h prime of 10 is going to be 5.5. So that'll be our estimate of h prime of 10. Okay, and then we do the same thing for each of the other table values. We're going to go to 20 next. Again, for 20, we have two choices. We could either look at the interval between 10 and 20 or the interval between 20 and 30, the right interval or the left interval. We're going to do both, the average rate of change over both intervals, and then add them together and divide by 2. I've already done the interval between 10 and 20. The average rate of change was 7. So I don't have to worry about 20 to 30 now. So let's do that computation. Between 20 and 30, the average rate of change is 300, the difference in the y values, minus 120, and then divided by 30 minus 20. So that's going to be the same as 180 divided by 10, which is the same as 18. So the average rate of change over this interval is 18. Now I'm going to take the average of these two numbers, so I have 18 plus 7 divided by 2, and that gives me the best estimate of the average of the instantaneous rate of change at 20. So this is 12.5. So that's saying that after 20 seconds, Tristan's hair is growing at a rate of 12.5 hairs per second. Okay, and then we can move on to understanding what happens at 30, and to do that we'll do average rate of change here, which we've already computed, plus the average rate of change here, which we need to compute, and then divide by 2. So the average rate of change on this last interval is 310 minus 300, change in the y values divided by the change in the x values, which is 40 minus 30. So the average rate of change is 10 over 10, which is 1. Things have started to slow down. So average rate of change there is 1. So to find this number, I take the two average rates of change and average them. So I have 18 plus 1 divided by 2, which is 19 divided by 2, which is equal to 9.5. So 9.5 will be my estimate of h prime of 30. Okay, and then one last table item to fill in. What happens at 40? What's my best estimate? Well, I don't know what's happening at 50, so I can't, there's a question mark here. I don't know what to do because I don't have that data. I only have the data between 30 and 40, so that's the best thing I can do. And the average rate of change there was 1. So that's the best. I don't have anything to average it with. I just have this one data point, 1. Okay, so this shows you how to fill in a table of values for the derivative given information about the original function.